A turbine is working under a head of 40 meters and at a speed of 1100 rpm. The power developed is 1200 kilowatt. Determine the speed and power when the head is reduced to 20 meters. Here there is a turbine and this turbine is working under a head of 40 meters. So here head is 40 meters and at a speed of 1100 rpm. So here speed of the turbine is 1100 rpm. The power developed is 1200 kilowatt. Okay. So you given head, speed and power. Okay. Next, determine the speed and power. So we need to find again speed and power when the head is reduced to 20 meters. So here we have two heads. Initial head is 40 meters. Okay na? Initial head is 40 meters and final head. Okay na? So here reduced head is 20 meters. So initially the turbine is working under a head of 40 meters and that head is reduced to 20 meters. So let us consider initial head H1 and final head H2. Okay na? So and here we need to find speed and power. Okay na? New speed and new power. Okay na? Initially given speed 1100 rpm and power 1200 kilowatts. So to solve this type of questions, we have to apply the concept of unit quantities. So unit quantities concept use cheyali ikkada. So unit quantities in the sense unit power, unit speed and unit discharge. Unit power, unit speed and unit discharge. So what is the use of unit quantities? Using unit quantities we can study behavior of the turbine when turbine is working under different heads. Okay na? So we can study behavior of the turbine when turbine is working under different heads. Okay na? So ante oka turbine behavior ni study cheyochu. Okay na? Speed, power, okay na? And discharge when turbine working under different heads. So మనకి ఇక్కడ టర్బైన్ టూ హెడ్స్ దగ్గర టూ డిఫరెంట్ హెడ్స్ దగ్గర వర్క్ చేస్తుంది ఈ క్వశ్చన్లో. Here initially given that the turbine is working under head of 40 meters and later that head is reduced to 20 meters. So ఇలాంటి క్వశ్చన్స్ వచ్చినప్పుడు we have to apply this concept, unit quantities concept. Okay na? In unit quantities concept we have three quantities. The first one is unit speed. So unit speed is equal to n by root over h, where n is speed of the turbine and h is okay na working head. And second one, unit discharge, qu is equal to q by root h. And one more quantity, pu. Pu means unit power. Unit power is equal to p by h power 3 by 2. So these three quantities are called these three unit quantities are called unit quantities. These are called unit quantities. Okay. So ఈ formulas ని యూజ్ చేసుకొని ఇప్పుడు ఈ ప్రాబ్లం మనం సాల్వ్ చేస్తాం. Let us write given data. Here given data, a turbine is working at a head of 40 meters. So given data. First of all, list out given data. So initial conditions. So initial head of the turbine H1 is equals to 40 meters. Initial speed is equals to 1100 rpm. And initial power P1 is equals to 1200 kilowatt. And final head, a reduced head, reduced to a head of 20 meters. So final head 20 meters. We need final speed and final power. Okay. So or speed of the turbine when turbine is working under a head 20 meters, or speed, okay now, power developed by the turbine when turbine working under a head of 20 meters. Okay na? So ఈ హెడ్ దగ్గర స్పీడ్ ఎంత, పవర్ ఎంత. ఇనిషియల్ ఈ హెడ్ దగ్గర ఏమైనా స్పీడ్ మనకి 1100 rpm, పవర్ ఏమో 1200 kilowatt. And what about speed of the turbine and power of the turbine when turbine is working under a head of 20 meters? ఇది క్వశ్చన్. సో ఇక్కడ నేను ఏ కాన్సెప్ట్ యూజ్ చేస్తాను? యూనిట్ క్వాంటిటీస్. So very important, unit quantities. So according to unit quantities, unit speed is equal to n by root over h. So from this formula, n by root h. So suppose we have two different parameters, two different values, two different set of values, then n by root h can be written as n1 by root h1. So initial conditions is equal to n2 by root h. Okay. So from this formula we can write it as n1 by root h1 is equal to n2 by root h2. Okay. So this ratio is always equal. Okay. So anyhow, n1 by root h1. So first of all, we need n2. Transpose root h2. n2 is equal to division becomes multiplication. Transpose root h2. So n1 into here root h2, here root h1. So root h2 by in denominator we have root h1. So then transpose cheste multiplication emotundi, sorry, division emotundi, multiplication. Okay na? So n1 into root h2 by root h1. It can be rewritten as n1 into root a by root b, root over a by b. Okay na? So root a by root b, root over a by b, root over h2 by h1. So root over h2 by h1. So n2 is equal to, now substitute all the values. n1, what is the value of n1? 1100 rpm. 1100 into root over h2, final head 20 meters, by initial head 40 meters, 21s and 22s. n2 is equal to 1100 into root over 1 by 2. Now n2 is equal to 1100. It can root 1 value 1. Root 1 value 1. So 1100 into 1, 1100 by root 2. So if you calculate 1100 by root 2, you will get answer 777.82 rpm. 777.82 rpm. This is the speed of the turbine when turbine is working under a head of 20 meters. And next we need power. So we know that unit power is equals to, what is the formula for unit power? So unit power is equal to P by H power 3 by 2. From this formula, if you consider two different cases, two different conditions, then it can be written as P1 by H1 power 3 by 2 is equal to P2 by H2 power 3 by 2. So P1, H1 are the initial power and initial head, P2, H2 are the final power and final head. Okay. Now here we need P2. So transpose H2 power 3 by 2. You will get P2 is equal to, division becomes multiplication, P1 into H2 power 3 by 2 by H1 power 3 by 2. So P2 is equal to P1 into, it's like A power m by A power n. A power m by, sorry, A power m by B power n. So A power m by B power, A by B whole power n. A by B whole power m. M value 3 by 2. Okay na? So A power m by B power n. A by B whole power n. So P2 is equal to, so what is the initial power? 1200 kilowatt into H2 120 by H1 40 power 3 by 2. 21s and 22s. Now P2 is equal to 1200 into, here you will have 1 by 2 whole power 3 by 2. So if you simplify this, you will get a final answer. P2 is equal to, you will get final power 424.26 approximately kilowatt. So you will get final answer as 424.26 kilowatt. So final speeds 777.82 rpm and final power 424.26 kilowatt.